Okay, so this is the food burning lab. I'm just going to give you a little bit of a start with some of the problems. I'm not going to actually do any of the problems for you. It's just kind of to get you to start, a jumping off point. So you filled in all this information, of course. All work must be shown to receive credit. Calculate the mass of water using the density formula. So density of water is 1.0 gram per milliliter. So density equals mass over volume. We know that the density of water is 1. Put it over 1 if you'd like. We know that the volume of water in every trial was 85 milliliters. We don't know our mass, but we will in 30 seconds or less, because hopefully you can do that. So actually I will solve this one for you. So your mass is 85 grams. Okay? You are going to be using 85 grams for the mass, not the mass of your food. That's something different. Calculate the Q for the water in joules for each trial. Use the mass of water for M. So whatever you have for your food item 1, you're going to use the formula Q equals MC delta T. And you're actually going to use that formula for each of these. You're going to write it 4 different times. Q equals MC delta T. Okay. So in my calculation, so our mass was 85 grams because it's Q for water. The specific heat of water is on reference table B. It's 4.18 joules per grams degree Celsius, or joules per Kelvin, but we didn't measure in Kelvin. Now, delta T, this is final minus initial. So for example, if I had, for the Fruit Loop, let's say I had, and I don't remember what it was, I'm just making this up on the spot. So let's say I had a final temperature of 17 and an initial of 15. That means I would put 2.0 in here. And I'd solve all that, and I'd get my answer, and the units would be in joules. Then I would do it for the next one, and the next one, and the next one. Okay? Then I'm going to convert those joules to kilojoules, knowing that a kilojoule is 1,000 joules. Note, use the calculated Q values in question 2 as the measured quantities. So let's just say, for the sake of example, I'm going to do that first one with the made-up data. So 85 times 4.18 times 2. So I will actually solve this. It is 710.6, which really should be to 2 sig figs, so 710, but we'll let that slide. Now, I need to convert that joules to kilojoules. So 710.6 joules times my conversion factor, which is 1,000 joules on bottom, 1 kilojoule on top. So joules cancel out. So what I have to do is divide by 1,000. So divide it by 1,000, and you get 0.7106 kilojoules. They should look pretty similar, okay? So you're going to take your answer here, and you're going to do it here. You're going to take your answer here, and you're going to do it here, and you're going to take your answer from here, and you're going to do it here. Okay? Then you're going to convert joules to calories. So there are 4.18 joules in every 1 calorie. That value is in the notes. Use the calculated Q values from question 2 as the given quantities. So going back here, 710.6 is where we start. And we're going to convert to calories. So if we're converting to calories, it's on the top. Calories on top. 4.18 is on the bottom. Goodbye to that. So in my example, we're going to do 710.6 divided by 4.18, and I get 170 calories. Okay, and you're going to do that same conversion, blah, 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 times 1 calorie over 4.18 joules, get the answers. Now we're going to take those calories and we're going to convert them to kilocalories. Remember, this orange is too much. 1 kilocalorie is 1,000 little calories. Note, use the calculated value from question 4 as you're given. So I'm going to need that 170 here. Now to convert to kilocalories, which is what I want,
divide by 1,000. So 170 divided by 1,000 gives me 17 kilocalorie. Okay, show all your work. Show your units. Calculate energy in kilojoules per gram for each food item. Okay, so now we finally get to use the mass from the front page for each of those individual food items. So food item number 1. So we're going to use kilojoules per gram. So kilojoules was 0.7106. 0.7106 kilojoules. And then I'd go back to the first page and I'd find my mass of food, which I'm just going to pretend is 0.50 grams. It wasn't, but I'm just putting that in there. So 0.50 grams goes here. And all you do is you just divide them. Energy is kilojoules per gram divided. So 0.71, hold on, 0.7106 divided by 0.5 gives me 1.4212, which I shouldn't have that many decimal places, kilojoules per gram. Done. So I take my energy, which is question 3, and then I'm going to do that over the mass of the food. And my units are kilojoules per gram. Finally, the last question is, based on your calculations, which food would be best to bring on a long hiking trip, where you would want to get the most energy for your mass? Basically, which is the most bang for your buck? So which has the greatest kilojoules per gram? And then explain. Okay, if you still have any remaining questions, please ask. Otherwise, thanks for watching.